Hello. Okay, so basically, most of you are not doing things that make a lot of sense when it comes to thinking about the part, the whole, and the percent. So we need to be very strategic when you're talking about what is the percent in a situation, what is the part in the situation, and what is the whole in the situation. So to encourage you to do that, I have 3 equations here and 2 scenarios. And I want to know for each of these scenarios what equation is going to match with the information that we know and that we don't know in the scenario. So the first one is, there were 40 questions on a test and Jakaya got an 80%. How many questions did she answer correctly? So in terms of information we have, part, whole, percent. There were 40 questions on the test, that's all. That would be our whole here. And she got an 80%, that would be our percent. So the information that I'm trying to find out would be the part. I've color-coded this for myself. Feel free to do the same if you feel like it. So we talked about this a little bit in class. If you had, for example, 30 questions correct out of 40, how could you represent that? And a lot of people said that they could use a fraction. They could say, oh, I got 30 out of 40 correct. That would be like 30 over 40, 30/40ths. So given that, of the equations that we have here, only one of them has something that's out of 40, where 40 would be in the denominator. We don't know how many questions they got correct, so you could use a variable. And then the score would be an 80%. So if you look at this equation here, we have that our wholes match up. 40 questions is the whole test. 100% would be getting a perfect score on the whole test. X is what we don't know. We don't know how many were correct, but we do know that that is 80% on the test. So I'm going to quickly color code that. To think about kind of your part of your whole is going to give you information about the percent value. So if I wanted to put that onto the percent bar, from the things we talked about last week, we know the whole is going to always be 100%. And in this case, we know that the part needs to be 80%. Okay, so our whole is our 40 questions, our 100%, and then our part here would need to be that 80%. And I could use that to solve, to figure out what would be my percent value. You might want to think about breaking it down into 5 pieces of 20%. You could break it down into 10 pieces of 10%. That would be a way that you could break the percent bar down. Next, we've got Dantel got 40 questions right on the test, and he scored an 80%. How many questions were on the test? Well, he got 40 right, but we don't know how many were on the test. So 40 in this case would be our part, and the questions on the test is our whole. Same percentage score though, we know he got an 80%. So looking at that, I don't know the whole anymore. I don't know what the original test score was, so that would have to be my denominator of x, but I know that he got 40 right. So 40 out of the whole test. And that needed to equal 80%. Color code that. So the wholes match up. The entire test is x and 100% of the test. And then our parts, getting 40 correct, and that is an 80%. That matches up. On here, that would look like knowing the part, knowing that that is 80%, not knowing the whole, but knowing that it is 100%. And once again, we could break it down. In this case, we would still probably want to think about how you could break it down so we pass through 80%, and then how could you also use that to figure out what pieces you would have in 40. So to generalize this, we've got that if you have the part compared to the whole in a relationship, that is going to be the same as the percent, which is always out of 100%. So you have your totals and you have your parts, and they always need to correspond. Your totals are in the denominator in this case, and your parts are in the numerator in this case. And your part is going to always match up with whatever your percent value is, and your whole would need to match up with what 100% in the situation would be. So on the back, we've got that Jalen made 40 out of 83 free throw shots in a free throw competition. I know he made 40 out of 80, so I can set that up looking like a fraction. 40 would be my part, 80 would be the in all, and I need to know what was his percentage. So what percent out of 100? People did some really nice things with this. Some people thought about it visually, other people looked at that 40 out of 80 and decided to break it down right away. We could do that. If you have 40 80ths, you could divide that right away by 40, and you would have 1/2. You could also keep cutting it in half until you got to that point, but you would eventually reduce that fraction all the way to 1/2. And that would tell you, well, 1/2 is 50%. So right away, that tells you that you're going to need to be at 50% out of 100%, and that's going to correspond with 80 free throws out of 100 free throws. Nice. So that's where using the proportion can be very useful, because you can figure out, you can always start right away trying to simplify that fraction. On your homework for tonight, I ask you to write a proportional equation, just like this, where you're thinking about what do you know and what don't you know, as well as drawing me a percent bar so I can see what that's going to look like visually. I should not see anybody just multiplying numbers at random. You need to be thinking about what is the part, what is the whole, what is the percent, and how are they related in this situation. Have a good night.